I have, by your request, I have my video on. If there's any problem with the bandwidth, let me know, and I will disable the video. Thank you very much for the invitation to summarize here a workshop which we did jointly at Brookhaven National Laboratory and Jefferson Lab, Future Trends in Nuclear Physics Computing. Before I go into the details of the workshop, I would like to shortly say a few words about nuclear physics. So in the further exploration of the standard model, where we look at gravity, electroweak interactions, nuclear physics focuses on the strong interaction. So the mission of the nuclear physics program in the US is to discover, explore, and understand all forms of nuclear matter. The research I'm personally involved in is really to understand the quark-gluon structure, the dynamics between the quarks and gluons inside of nuclear matter. The workshop, as I said, was jointly organized by BNL and JLab. And the organizers of the workshop are Alexander Kiselev, Amber Böhnlein, Graham Hayes, Mark Ito, myself, Arthur Rindt, Paul Lecoq, and Tore Venus. It continued a workshop which we started in 2016 at Jefferson Lab. Around this time, we had it was an in-person workshop with 76 participants, and we really wanted to look at the future, examine our computing strategy at the time horizon of a decade, look if we can come up with a common vision for nuclear physics computing, and recommend future directions for the developments. I linked the website of the workshop with quite some interesting presentations. The workshop was very well received, so we continued it a year afterwards, also in person, 74 participants, and we continued the discussion, but this time we really wanted to look onto how to improve analysis based on trends in scientific computing. And with analysis, we also really wanted to look at data, and we wanted to work towards the next generation analysis techniques and tools. Website is also linked here. This year, we continued the workshop. It was now the third one, not in person, it was fully remote. And we wanted to focus on the nuclear physics software and computing community. So we really wanted to identify what is unique of our community, how could we strengthen common efforts inside our community, but also with other communities. And by doing so, chart a path for nuclear physics, software, and computing for the next 10 years. We had 207 participants. You see one of the Zoom screenshots here. And we really want to thank the HEP Software Foundation. We really wanted to thank you for your strong support in promoting the workshop, and also your really very active participation in the discussions. This has been really great. How we organized the workshop, we had 3 days, and each of the 3 days, we had a time window of 4 hours, which we have chosen to be as exclusive as possible to join. So we had participants from the West Coast in the US, Europe up to India, where we discussed and really had substantial discussion time included in the agenda. Each day had one specific topic, common scientific software, moderated by Paul and Tore, the role of data centers in scientific discovery, moderated by Graham and Arthur, and unique software challenges for nuclear physics, moderated by Mark, Alexander, and myself. We adapted a strategy which has been successfully used for your workshops by having a Google document where to put in, to moderate it and record the discussion, to gather questions and discussion points from really all participants. And after the workshop, this was very helpful for summarizing and report writing. The live notes are frozen, and the link is here, and it has now, and it is in total 26 pages. So there was really a lot of discussions in the 3 days of our workshop. So one of the topics of discussion was common scientific software. We had 3 presentations on the subject, developing common software in ACTS, software sustainability, and developing common software in Rusio. We make no attempt to summarize the presentations. The slides have been excellent and stand on their own. And also really the speakers on all day really made the sessions and the discussions very interesting and very useful, actually as useful as we could hope for. And that was thanks to their really a strong contribution, but also really to all of the participants, because we really had stimulating discussions. There have been really challenging questions, and to these questions, really frank, open answers, which was really, really cool. So what is a summary of the discussion on common scientific software? The keys to success, according to our discussion, is the team, the project, and the management. The most important part is the team. And here an emphasis was made on the point to not separate development and operations. So for instance, in the examples which we discussed, ACTS and Rusio, they really benefited from experience in developing and operating let's say, verse software package. And by doing so, they really gained crucial experience for the development of their tools. And also important is that developers are really keen to use modern software paradigms. Open source, open-minded is here important. And open-minded also means proactively really search for best practices and adopt them. In addition to the team, the project and its management is relevant. So it was pointed out that that important for success are very clear, focused, short-time goals, which are really grounded in real-world deliverables. And that has to be then aligned with the long-term plan of building something which is sustainable and also designed to be used for outside collaborators. And that really requires the support of the management, because the management has to accept that the long view takes longer than deliver a short-time project. And this really also requires to manage expectations with the experimental collaboration and the funding agency, so that the development team has sufficient time and space to succeed in its mission to develop common scientific software. This also needs careers in scientific software need support. So there needs to be recognition, encouragement, and reward. And that really means that we need to make software citations a priority. Any hardware project in nuclear physics ends up on nuclear instrument methods, but this is not the case for software project. That needs to change. And also career path of research software engineers needs to be supported, not only at the labs, but also at universities. Part of this discussion was also the interplay with the HTTP Software Foundation. Should we at large join the HTTP Software Foundation or build up our own organization? The discussion went a lot about the pros and cons. The hesitation is mainly by the perception that the current topics of the HFS are around high luminosity LHC, but we are well aware of the fact that your organization is a bureaucracy. That means active participation means also active or strong visibility. And the discussion favored in a more strong participation in your organization. But we have to work with the reality that nuclear physics has small group in-house solutions. And I will comment on that later in later slides. The second topic which we looked at was the role of data centers in scientific discussion. How this role may evolve over the next decade. Looking in a particular role supporting long-term data and analysis preservation for experiments, and looking at the multifaceted interactions with the user base. The summary here is what are the factors which will define the evolution of the data center infrastructure? Well, there is artificial intelligence, machine learning, there is new hardware, we have GPUs, FPGAs is something which is very much discussed in the nuclear physics community. That creates some tension between HTC and HPC resources in planning. And this is also further emphasized than the US with their XSK computing program, really go into supercomputers with accelerated hardware. Another driver is the role of tape and cloud storage. The integration of distributed computing resources, and a topic related to that is federated authentication and authorization, so that it's easier to use all of this distributed computing resources within the lab infrastructure, but also beyond that. And of course, related to all of that is the evolution of high bandwidth networking. Another aspect is really long-term data and analysis preservation. Here it is important to not only preserve the raw data, but also preserve metadata and the software code along with it. Related to that is also to have documentation and a proper choice of tools for documentation. And really essential is to building data and analysis preservation into the infrastructure, and also have related policies at a very early stage. We really see that experiments who don't do this at an early stage struggle over their whole lifetime in adapting data and analysis preservation. There are challenges in developing common and relevant computing benchmarks for nuclear physics. This will continue a topic. For the interactions between facilities and stakeholders, this is a two-way communication. So on one hand, it was discussed how to educate users what the data center is doing, but also the stakeholders need to communicate their needs to the facility, which is the other side of the communication. The point which has been discussed, which is really important here to make this successful, is to not have a separation between facilities and users, but really embedded facility personnel within the experiments and vice versa, to really have a strong connection, a strong interplay. And also connect the operating personnel with researchers in computing science, being it at the labs or at universities. And last but not least, promoting computing within our community. So really to have support for education and training in software development, and related to the point previous about software citations and careers, provide career paths and fundings that allow for and value software development. This third day focused on unique software challenges for nuclear physics. Here we identified challenges from three perspectives. At JLab, the 12 GV science program has started. We heard about first experience from that. We heard about software challenges in streaming readout and related models for near real-time analysis. And we got input from a survey among a PhD student and young postdocs.
Markus, you have 5 minutes left.
Thank you, yeah. The discussion highlights here have been, there was an importance to have a really fast turnaround in data processing and having adequate monitoring and data quality tools, really get the physics analysis out fast. Also in that day as a challenge was discussed data and analysis preservation. Many big enough experiments do not yet have a working model in place. Streaming readout and data analysis preservation is a connecting topic. Both in the way data is archived, but also the possibility it gives for data mining. And related to the topic which I presented at the previous slide about education and training, also the point which was emphasized on the third day, quality tutorials are extremely important for teaching young students. A short question from the survey I just wanted to highlight is that we asked them what time do they spend on software and computing aspects of their research, and an average is 78% of their time that they spend on software and computing. So this is really an essential part, major part of everyone's work. Another a result of the survey, which I wanted to highlight, is we asked, are the computing resources you need readily available? And we got a quite interesting comment from a PhD student, a young postdoc, who said that that the funds are mostly spent on computing resources, but very little on computing expertise. So if we had half the computers and twice the number of software experts, we could be in a much better place. Interesting point also related to software expertise and all the questions which I mentioned in the previous slides. So what is the summary of the discussion? Well, what is the scientific problem space of nuclear physics? The focus is really on non-perturbative QCD phenomena. The Monte Carlo event generators, which we use, need to fold in spin-dependent measurements, including also novel QCD phenomena, for instance, GPDs, TMDs, etc. The analysis, we really have here a large number of signal events which we process simultaneously or even multiple times. This is contrary to separating a few events from a large number of background events. An example for that would be, for instance, analysis of GPDs or TMDs, where one looks into multidimensional, strongly correlated relationships among data. And another example is high precision results, which require a complex analysis to control the systematic uncertainties and estimate them.
2 minutes, Markus.
Yeah, I'm coming to. And and this requires really unique software and computing strategies. And with the relatively smaller size of experiments, this also goes along with shorter experimental life cycles and faster changes in scientific goals. We have a small group size, which means the collaboration size and average is smaller in nuclear physics than in high energy physics. There's really in our field the tendency to do their own thing. And even a larger experiment, there are individual analyses which are quite different, organized in small teams. And this non-unified approach has really inhibited progress in our field in the past. But now that we transition to experiment with larger data size and more complex analysis, this really drives working together and really address problems of the new scale of future experiments. But this requires careful planning to have a good mix of in-house development, adoption of outside packages, and the choice of appropriate scale throughout. And of course, it's a challenge in finding the right balance here. We have a workshop report, a draft ready, 28 pages and growing. We allowed 1 week for comments. Detailed comments have been given. Almost all of them are already incorporated. So we are currently finalizing the report and will then share this on the archive. You find the link here. And if you give a comment, even so the deadline is over, we definitely will consider it until it is really final and then on the archive. I have 2 more slides. In one slide, I shortly want to mention that there was consensus in starting a community forum for nuclear physics. There's an ongoing discussion how there will be the connection with the HEP software foundations. And the goals of this community forum will be in form of building successful scientific software projects, taking the unique challenges of nuclear physics into account, foster collaborative common software projects in nuclear physics, and promote scientific software career support. Related to this community forum is organized by the same group, the Software and Computing Roundtable, which we have since 2016. The role of the roundtable is to encourage knowledge transfer and promote common projects. It has, we explore the future of software and computing in HEP nuclear physics and beyond. And we really put the emphasis on the interplay of software and computing and science. The website is linked here, and you find also on the website or linked here on the slides, a news story which gives you a little bit on the history, on the background of the software and computing roundtable. That has been all. Thank you very much.
Thank you, Markus, for meeting the change of this very condensed or dense presentation, and for keeping your time so that we can have the time for discussion now. I am pretty sure that there are several people who may want to ask questions or discuss the things with you. So I remind everybody that if you want to speak, just use the raise hand button in the participant list. Maybe there were a couple of comments in the live notes. So in particular, Graham, I think you had a question about the training. Do you want to ask it?
Yeah, thanks, Markus, for the talk. That was a very nice summary. One area where I thought actually the collaboration that we could have is almost at the obvious level would be in training, because I think we find that a lot of the basic skills that we have to equip people with so that they can do software and computing effectively are in fact quite common between physical science disciplines, even discounting nuclear and high energy being extremely close cousins. So how do you, as a community, how do you do that training now? Do you do it? Is there an organized effort to do it? And how could it improve?
Okay, so I agree that this would be an ideal opportunity for collaboration. Before giving the presentation, I sneaked at your questions, and I saw your questions. So I put some results from the survey in. And so as part of our survey, we asked if people are able to perform the software and computing tasks needed for their research. And most people can do at least at a moderate amount. But when we ask them, are they confident in doing that? We really see that shift, that they only feel that to a moderate amount. Only a few, I mean, okay, still 20% say yes, they feel very confident in what we are doing. So where do people get their training? Even so, there was a case where someone said that they had over 10 computer science or programming courses, likely the one who said he's also a full-time computer science major. Most really had 0 or 1 course, and what was mostly mentioned was an introduction to software and computing in Python. And that then also reflects, where do people get their resources? Most of them is coming from online resources and from colleagues. The documentation itself, which is available, is reviewed as not necessarily inaccredited, but for sure requires optimization. And there were some critical remarks on that the documentation is outdated, awful, etc. So there is definitely room for improvement there. There is no coordinated plan related to what I described with smaller experiments doing their own thing. These smaller experiments have their tutorial sessions. For the electron ion collider, we had quite some software tutorial sessions, and we will continue that. But having some coordinated effort would really benefit.
So maybe there are many questions happening in the live notes, and there is also Doug. Maybe just as you mentioned something on Python, a lot of people using with Python training. Eduardo also asked about what is the uptake of Python and the interest for connecting to the PyApp meetings. Maybe you could shortly comment on this.
Yeah, there is a lot of interest. So in one of the EIC software meetings that I'm involved in the organization, we had a presentation on PyApp because this is very relevant. We asked the students and young postdocs, the common tool which everyone still uses is root, and then second is Python. So we really have a strong growing data science community in Python. And in particular, from what I know at Jefferson Lab, is the theory groups are quite advanced in using Python for their data science, also really then using Jupyter Notebooks, Jupyter Lab. And this is growing in the community, and of course there has been a lot of interest from our community who participated in this very successful PyHab workshop, which we will hear after my presentation.
Okay, good. Doug, you wanted to ask a question?
You talked about small. I also wrote the comment in the chat in the doc, but you talked about how nuclear physics experiments are typically small, or at least the work is small. But with EIC being such a big project, is that going to be really disruptive, and it will change the way you work?
Absolutely, and this is what I meant here with this comment which I have on this slide here, that the old culture cannot effectively address the problems of the scale of future experiments. And this is, therefore we had this workshop, and therefore we would like to start this this forum where we really would like to help with this culture change. We are well aware of this problem which you mentioned.
Markus, I had one question. You mentioned that the nuclear physics community was leaning, at least in the workshop, to participating to the HSA, but it was still a sort of an open question. Do you see anything that we can do on our side to make this easier? Because I think it is clearly in our identity, in our genes, to be open to others. So, if you have any suggestion that could help.
Yeah. For knowledge transfer, the software and computing roundtable, which I have mentioned, has been really helpful. In the next software and computing roundtable on December 15th, we have Graham, who will highlight the HEP Software Foundation. We have also invited the foundation to join the organization of the software and computing roundtable to just cross-promote each other better and encourage the nuclear physics community to join various working groups of interest. There was already PyHab mentioned, but of course in framework developments, detector simulations, Monte Carlo, event generators, all that has interest for nuclear physics, and this is also where nuclear physics can contribute. And this list is not limited. There are other working groups there. So I think having this cross promotion will help. For the future, what you could consider when appointing workshop conveners is maybe to really also have one from the nuclear physics community to really make these links stronger. But I think, given that you are a bureaucracy, I think this progress needs to grow over time, and what nuclear physics needs to do is just to more actively participate in your organization.
Okay, thanks. I think it was a very good proposal, and clearly we really want to thank you for this very positive feedback, and I think there are plenty of things that we need to do together and try to find a way to do it properly. And as you said, we need to accept that it will take time for this. So I think that, so thanks again. And
thank you very much.